Hello class and welcome to lesson 5.4b. Today we're going to be continuing the work on the CAST rule and taking a look at our trig ratios between 0 and 360 degrees. To start off with for our warm-ups, I thought we'd take a look at a couple homework questions. So we're going to take a look at 8b and 15a. 15a was one of your tricky questions, and because of the work involved I will show you why it's a tricky one. So take a look in 8b, folks. We take a look at the question given. We've got to find theta given that tan theta equals negative 0.1623. Well, first of all, we can find theta. Theta equals the tan inverse of that, which is negative 0.1623. Plug that in your calculator. Okay, and we can get that that equals, when you plug it in, 9 degrees. Okay, now before we put 9 degrees in on our grid here, folks, we've got to take a look at the CAST rule. In this question, notice that tan theta is negative. Therefore, what quadrants are we going to draw our reference angles in? So therefore, we got to be in quad 2 and quad 4. So now that we know our reference angle theta is here, we now know that it's 9 degrees. Okay. We can now figure out our values that correspond to that because the theta is our reference angle, so we're going to use that to help us figure out our angle. So the angle that comes terminally to this value is going to be here. Okay, and let's just call that alpha 1. Okay, so alpha 1 equals 180 degrees. Subtract our reference angle, which is 9 degrees. So that's going to equal 171 degrees. Awesome. Okay. Now that's one of the 4 quadrants where the tan is negative. And if you forget, you can write down the CAST rule. Okay. Where else is the tan negative? And you will find that it is in quad 4. So in quad 4, if I draw my reference angle here, we know that's 9 degrees. I apologize, I forgot my degree sign there, folks. We need to find our second angle that terminates at that line. So you go all the way around to here, and that's alpha 2. So to find alpha 2, okay, that's going to be 360 degrees. Subtract our reference angle, which is 9 degrees. So that equals 351 degrees. So therefore the angles are 171 degrees and 351 degrees. Okay? It doesn't matter, ladies and gentlemen, what symbol you use to initiate or to start this. I just use theta because that was the one given. Remember, your calculator is going to give you the reference angle. And we just let alpha be the angles that we're actually looking for, okay? So I'm not too concerned about what symbols you use as long as you know how to compute the solution. All right, taking a look at 15a, ladies and gentlemen, it is tricky. The reason why it's tricky is when we look at the expression cos 2 theta equals 0.642, there is a doubling property here. So proportional ratio would tell us that instead, if this is theta from 0 to 360, 2 theta is going to be double those limits. So it's going to be 0 degrees to 2 theta. What's 2 times 360 is going to be 720 degrees. So you've got to, if you're doubling the angle, you've got to double your restrictions or your limits. Okay. All right. Taking a look at the value, ladies and gentlemen, let's try to find that angle first. But in this case, instead of finding theta, we're going to find 2 theta equals the cos inverse of 0.642. Okay, plug it in your calculator, folks. 2 theta equals 50 degrees. To find theta, you got to divide both sides by 2 because it's proportionally twice the value. So theta equals 25 degrees. What we need to do now, that's our reference angle. We've got to find where do we plant our reference angle. And that goes back to the original question. So cos is positive in this case. So what quadrants is cosine positive? It's positive in quad 1 and in quad 4, according to the cast rule. So we'll plant our first angle here, and that's 2 theta, folks, because that's the value given. So we plant 2 theta there. Okay, and to find our initial arm, it's going up here, and then we split it into 2 to get 25 degrees. Our second quadrant that we find our 2 theta in, ladies and gentlemen, is in quad 4. Okay, so if I put my reference angle in here at 2 theta, and the angle I want to find is from the initial arm all the way down to that terminal arm. Okay, and let's call that theta 1. The thing we need to remember, folks, is it's a proportion of 2. So instead of theta 1, I'm writing down 2 theta 1. Okay, because that's what this value is based on, the 0.6420. Okay, so 2 theta 1 equals 360, subtract 50 degrees. Okay, so that equals, so 2 theta 1 equals 310 degrees. And again, to get theta 1, you divide both sides by 2. So in this case, theta 1 equals 155 degrees. Now we could be checking our restrictions here, folks. Just remember that this first value of 310, that applies to the extended restriction of 0 to 720. Whereas your second answer here, that relates to the initial restriction, which is 0 to 360. So we have to keep going until we reach those limits, because these are still well within the limits that are set here. Okay, what does that mean, folks? Is we've got to go back to quadrant 1 again, put 2 theta, and realize that, hey, we've already done the initial 2 theta 1, or our reference angle, but this time we're going to go all the way around and come back to it. Okay, so in this case, if we call this alpha 2, folks, it's going to be 2 times alpha 2, because of the proportionals, equals 360 degrees plus 50 degrees. Plug that in your calculator, you're going to get 410. Okay, but that's 2 times theta 2. So theta 2, if you divide both sides by 2, that equals 205. Okay, so there's another angle. So far, in this, we found one angle here, we've got a second angle here, and here's our third angle. Looking at our restrictions, both of these still fit in, so we've got to still keep going. So let's put it in quad 4, and again, do a complete rotation to come back to it. So let's put in 2 theta here, guys. Okay, we're going to start here, we're going to go all the way around and stop there. Okay, so taking a look at this, let's call this alpha 3. Okay, so 2 times alpha 3 is going to equal 720, because that's 2 times around. Subtract 50 degrees, which is the reference angle. Perfect. Okay, and that, if you put in your calculator, you get 670 degrees. But again, that's 2 theta 3. So theta 3, if you divide both sides by 2, equals 335 because of proportionalities. Okay, so there again, we have found another answer. And is that still within the 0 to 360? Yes. So we've got to keep going to see if we're at the end yet or not. So again, we're going to go back to quadrant 1, which would be the next biggest angle. And this time, we're going to go all the way around twice and come back to it. So we'll try this. Go once, twice, and come back to it. Okay? So what we really have done is 2 complete rotations plus the reference angle. So if we call this alpha 4, 2 times alpha 4 equals 360 plus 360, because that's 2 rotations, plus our reference angle, which is 50 degrees. Plug that in your calculator, you're going to get 770 degrees, which you should recognize is outside of the bigger limit, because the bigger limit stops at 720. If you don't, you could divide both sides by 2 and get that alpha 4 equals 300 and, is it 85, I believe? I could be wrong. 385. Let me just double check that. Double that. Double that. Yeah, I think that's right. Okay, and that is outside of our limit. So these two are outside the restrictions. Okay, therefore you do not include, so we cancel that one out. So we do end up with 4 angles here, folks, for this answer. So therefore, theta or angles is 25 degrees, 155 degrees, 205 degrees, and 335 degrees. That's why that was a tricky question. I want you just to reflect quickly, guys. Most cases, we only have 2 angles, like the first example, right? When you're restricted theta being from 0 to 360. But in this example, guys, remember, it was 2 times the theta. So it's going to be 2 times the number of angles, so that's why you would have 4. If it was 3 theta, guys, you would have 6. Okay, hopefully you don't do 3 theta because that's pretty tricky as well. Okay, so just take a look at your restrictions and make sure they fit in there. And if theta has been either added, subtracted, or multiplied, you may have more than 2 answers in your solution. All right, let's take a look at today's lesson, ladies and gentlemen. Today we're expanding upon our CAST rule, but we're going to use a point instead of a reference angle to help us get started. Okay, so let's take a look here. All right. So all we're doing, folks, is saying a point, and we could put any point, okay? Any point, we'll call it P, X, Y. And if we draw a straight line from any point to the center of your Cartesian plane, we call that R, which is the radius. And then we can break down what we call Pythagorean theorem to help you find that. So if I was trying to find the side length of this R here, folks, you would write down R squared equals X squared plus Y squared. Hopefully you recognize, hey, I've seen that from grade 10, and that is the equation of a circle. Okay, so that's what we're going to take a look today at doing. Okay, so what we're going to take a look at is the angle theta. We can take a look at making some SOHCAHTOA ratios or some trig ratios from it. So the sine, ladies and gentlemen, remember, is the opposite, which in this case is the value of y of your ordered pair, divided by the r, which is your hypotenuse. Okay? If we're trying to find the cosine of theta in this diagram, it's the adjacent side, which is x, over your hypotenuse, which is r. And tan, ladies and gentlemen, is the opposite, which is y over x. So if you're given a point, ladies and gentlemen, you have to find r. And to find r, you take the square root of x squared plus y squared. Awesome. Okay. In quad 1, ladies and gentlemen, so this is in quad 1. Remember, in quad 1, the reference angle will equal the principal angle. That only occurs in quad 1. In all of the other quadrants, the reference angle is closest to the x-axis. So in this case, our reference angle is going to be beta. Okay. So in quad 2, this is a quad 2 example. And in quad 3, quad 4, again, the reference angle is not going to equal the principal angle. So in this case, beta is going to be the reference angle. And again, they use different symbols. B does not necessarily always indicate reference angle, and theta doesn't always indicate principal angle, but we're just looking at this diagram, okay? And in this diagram, theta equals the principal angle, okay? And the thing we need to remember, ladies and gentlemen, is that, and r, we can add in r, folks. R is still the same distance. Okay, so r is the radius, which used to be called the hypotenuse when we were taking a look at SOHCAHTOA. Okay, and that's the distance from the point to the origin. And the thing I want you to remember, folks, is that with the reference angle, this is what the calculator gives us. Okay, so the calculator gives us this. Okay, And we're going to learn some patterns between the principal angle and the reference angle, i.e., when we plug into the calculator, ladies and gentlemen, a sine of maybe 25 degrees or the sine of 180 subtract 25 degrees, you're going to get the same result. Why is that? Because both the reference angle and the principal angle are located, the terminal arm is at the same spot. Okay, so that's why they equal each other. So I want you to write in here that the sine of beta equals the sine of theta. Okay, or and that same would work with cos or tan, ladies and gentlemen. All right, awesome. Let's show you an example and we can figure out how to do this. So example 1 is a point -815 and it's on the terminal arm of angle theta. So let's plot point -815. Again, the ordered pair will tell you automatically which quadrant it's in, and you should know that it's in quadrant 2 because it's -x. So if that's -8 and 15 up here, doesn't matter exactly if it doesn't look correct, okay, or to scale. And we're going to draw a line from that point to the origin. So that is point -8 and 15. Okay, and theta is the angle we're looking for, which is from the initial arm to our terminal arm. So that's theta. Good. So what we need to realize, folks, is that this is my reference angle, and the green one is my principal angle. All right, but what do we know, folks? We know already that if we drop a 90 degrees down here, okay, our vertical movement is what value, guys? It's the y component. So y is what we're looking for in our ordered pair. So that's 15. Whereas our horizontal movement, guys, is -8. We can use that to help us find the radius. Okay, so you could do this one of two ways. You could say r squared equals 15 squared plus -8 squared. Or you could just right away go r equals the square root of 15 squared plus -8 squared in your calculator. Regardless of which way you find it, plug it in and you should get that the radius equals 17. So 17 is our radius. I added onto my diagram. All right, now it says for question A, calculate sine theta, cos theta, and tan theta. Just remember that the sine of the reference angle equals the sine of the principal angle. So we don't necessarily need to worry if we're using beta or theta, but in this case it asked for theta, so we'll just do it that way. But we will use this to set up our ratios. So I'll show you an example. So sine theta, we could use theta or beta. I'm going to use beta because it's inside the triangle and I can easily do my my ratios that way. So from beta, which is still the same as theta, and you take the sine of it, the opposite side is 15 divided by the radius, which is 17. Okay, taking a look at cos theta. Okay, cos theta, ladies and gentlemen, is the adjacent side. So in that case, this is -8 over the hypotenuse, which is 17. And the last one it's asking for is tan theta. Tan theta equals the opposite, which is 15, over -8, which is your adjacent side. Be careful here, folks. You don't want to leave it like that. The negative can't be part of the denominator. So you just bring it out front or up top. It doesn't matter. But make sure you have that in proper form. All right, that's question A. Question B asks us to calculate the value of theta to the nearest degree. Remember, if you're taking tan of the alpha and tan of theta and tan of beta, it's going to be the same value. It doesn't matter. You could choose this ratio to do it. You could choose this ratio to do it. You could choose this ratio to do it. They will all give you the same answer. So let's just take a look at using sine theta, which equals 15 over 17. I naturally do whatever one is coming first. Okay, so theta equals the sine inverse of 15 over 17. Plugging that in your calculator, theta equals 62. Okay, And again, that gives us our reference angle. Okay. So that is our reference angle. So you could, in this case, use beta as your diagram matches. So maybe it's easier just to change these because remember, beta and theta equal each other when you're taking the sine of them. Might be easier to do that, folks. So you know that's your reference angle, just so the symbols match your diagram. Okay, and then to find theta, which is your principal angle, you're going to take 180 degrees, and you're going to subtract your reference angle, which is 62 degrees. Okay, plug that in your calculator, ladies and gentlemen, and you will get 118 degrees. Awesome. I'm just going to pause for a quick sec, and I'll be back. Sorry about that, guys. I'm back now. Okay, let's take a look at example 2. Example 2 is a little different in that I don't necessarily give you a point. I give you the ratio and tell you what quadrant it is in. First of all, you could get a question in your homework which says tan theta equals negative 3 over 4. Just remember, where is tan negative? Let's just use our cast rule for a second, guys. Okay, so one part where it's negative is in quadrant 2, and it's also negative in quadrant 4. But it tells us we're in quadrant 4, ladies and gentlemen. Okay, so we're going to take our initial arm and go to there, and that's going to be alpha. And just to keep consistency with our lesson, we'll call beta our reference angle. All right. If they didn't tell you guys that it was in quadrant 4, you would have to do it in quadrant 2 as well. But in this case, it tells you. So we're only going to have one answer here. All right. So what you need to realize, folks, is that with this question, they have given you the tan theta equals negative 3 over 4. If we apply it to the ratio we've learned, we should know that that is y over x, according to the formula, which is the opposite side over the adjacent side. Okay, so what does this tell us? This tells us that y equals negative 3 and x equals 4. Okay, so what we can do here, just in case you're not sure, is now we can tell you what that point is. Okay, so it's 4 and negative 3. So negative 3 is that value, 4 is that value, which tell you now we've got this point, 4 and negative 3. All right. One piece that we need to find out, because it asks for the sine and the cos of this angle, is in order to use the sine and the cos, we've got to find the radius. So to find the radius, r equals the square root of 4 squared plus negative 3 squared. Plug that in your calculator and you're going to get 5. You may have recognized that as a different type of special triangle, 3, 4, 5 triangle. You may see that in future lessons as well, if you didn't recognize that. So now that we know r, x, and y, we can now do the sine and the cos of theta. So plugging that in, sine theta equals, again, you should remember that it's y over r, which equals, in our case, negative 3 over 5. The next one is the cos of theta, and the cos of theta, ladies and gentlemen, is x over r, and that's going to equal 4 over 5. Good. So that's A part. Okay. B part, what does it ask us for? B part says to find theta. Well, I would always use the values that are given. So if we have beta here, okay, the values that were given were the negative 3 and the 4. You could use the r as well. However, we tend to use the ones that are given just in case we made a mistake calculating our radius. So we're going to use the tan inverse of our opposite, which is negative 3 over 4, because that's what was given. So let's find that value, plug it in. Okay, and when you plug that in, ladies and gentlemen, you will get negative 37 degrees. That makes sense. It should be negative because in quadrant 4, it is negative. Okay, and the 37 degrees is basically, folks, if you take a look, it takes this value, I'm just going to use this, and it drops it down. So you're going negative direction for 37. So that's what makes that, why that makes sense. But to find your principal angle, theta, so principal angle equals 360 degrees, subtract your 37 degrees, okay, which equals 323 degrees. Okay, and that again is your principal angle. All right, and just to make sure we're consistent here, guys, this is your reference angle. All right. Okay, let's do one last example here before we assign some homework. Use point 0, 1 to determine the values of sine theta, cos theta, and tan theta. Now, the tricky part here, ladies and gentlemen, is when we go to draw on our grid, you're going to notice that when you plot point 0 and 1, it's actually on an axis. So if I draw a line down, there's a couple things I can figure out. First of all, because I've got my point there, we know automatically that x equals 0, y equals 1. But what's my radius have to be, guys? It's the distance from my point to the origin. We also know that r equals 1. Okay, so the angle we're looking for is from the initial arm to the terminal arm, which is theta. Okay, so it asks us for the sine of 90, the cos of 90, and the tan of 90. So just remember, sine theta, the original formula, equals y over r. Sub in what we know, sine of 90 degrees equals my y, which is 1, over my r, which is 1, and that equals 1. Let's do the next one, cos. Theta equals x over r. Okay, sub in what we know, cos of 90 degrees equals, your x is 0 over 1. Plug that in your calculator, guys, and you will get that that value equals 1. The last one is tricky. Let's take a look at it. Tan theta equals y over x. When you plug this in, it's 1 over 0. Plug that in your calculator, and what are you going to get? Hopefully it says error in your calculator. Okay, please do that if you haven't done it. So what does that tell us? It's undefined. Just remember when we did slope back in grade 10 and grade 9, if there's no rise or run, i.e. a vertical line, that's called an undefined slope. All right, great. Here is your homework today, folks. Page 299, numbers 2, 6, 10, and 12. Have a great day and see me if you need any help.